disk. I'm going a little bit faster here. I did run strings. I'm going to do it again just to see. Gina DLL, that indicates it's a credential stealer. Let's open. Let me go back. These WLX also indicates it's a credential stealer. These imports. Actually, I want to go to resource hacker. Okay, there's something here. I'm going to export it. Forget exactly. Save resources, a binary file. What kind of file it is. Item free. Oh, I opened the wrong program. I do want to get there eventually. But, go resource. Okay, there's a valid program in here. Alright, so we have something in there that's a valid program, either DLL or an EXE, it turns out. So when I run the program, this pops up, msgina32.dll. That indicates that it's intercepting logins. So I'm going to reboot and well, I want to open this first. And I hunted around in here for a few minutes. That's not the one. I'm going to open Gina. MSGina32. Okay. Now what I found out in here is if you get a little bit further, there's a file right here, msutil32.sys, and that's key. Turns out that's where it stores the information, and it's under Windows sys32. Weird. See, if I log off, then it flakes out and it gives me the blue screen. Well, last time it did. Let me try it again. That worked. Okay, we have a file here, MS32. And, oh, by the way, let me go back into IdaPro in this program, Gina, MSGina32. All I did was, I went through, to find the file name of where it's logging the key, logging the passwords. I simply went through this, and I kept hitting, well, over further and further to look. I forget if I used right here or down here. Which one was that? But I kept going across and seeing more and more. Okay, I hold down my left mouse button and drag further and further here. Until I got to there, seeing this blue. Just to browse all the code. That's pretty good. So now we're going to open the file. Open with. Open with. Select program. Okay. So this is the old password. Or no, this is the current password. And that is all for Lab 11.1. Lab 11.2. Analyze the malware found in Lab 11.2 DLL. Assume that a suspicious file named Lab 11.2 INI was also found with this malware. I'm going to run strings on it. Interesting. Down near the bottom we have the names of executables, which apparently are email files, email programs. And then we have the send text and WSOC32 DLL, which is where I believe send is within. Send is an export in there. Then we have a possible host-based indicator. Spool VX32.dll. And this is really important, app init DLLs. Because you look back, let's see, where is this? I believe it's under persistence mechanism, yes. It's a persistence mechanism where anything listed under HKLM software, Microsoft, Windows NT, current version Windows, which turns out to be this right here. Any DLLs put under there will load. For any processes that contain user32.dll. Any executables, when they start up, if they contain user32.dll, they'll also contain whatever is loaded. So it looks like it might be trying that for persistence. Let's see what else. I don't see too much else in there. Resource hacker. There's no embedded resources. Doesn't look like. Let's see what else. Okay. What exports are in the DLL? Well, we can find out by going to dependency walker. Well, I'm actually not quite sure if this shows exports. It may only show imports. I've never come in here to see exports. if all else fails, we can go into IDA Pro. That'll definitely, we'll be there eventually. Okay, installer is the name of an export. What happens if you attempt to install this malware using run dll32.exe? It puts a file in Windows System 32, which I'm going to go ahead and see. And you can see it from Procmon. That's how you determine location. And plus, after you run it, you can do a search for that the DLL that's listed in strings here. Spool vxx32.dll. So installer cd desktop run dll32 lab 1102.exe installer. Oh, it's I did that before DLL here. Okay, I was pretty sure I put it under System 32. Maybe I'm wrong. Go to the enter. I'm trying to find something with the modified date, but I'm not finding it. So the modified date might not have been updated. Let me look for the name of that one DLL we found in strings, which is spool. There we go. We kept the same old date. And then if we look, process monitor, did I stop this? Let's stop it. Somewhere in here it'll show. Then it happened. Oh, excuse me, I forgot. I have to do a filter on run 32 DLL. Run DLL 32.exe. And then if I say filter detail contains this file. puts it in. This is a registry entry. Maybe that filter obviously didn't find it. The file copy. I'll change detail to something like I don't know what to do. Operation path and apply. Okay, there's a lot more. Path contains spoofy. Create file. Yeah, that's the location. So it's over here. I don't know what to make of the detail, but this shows that it did place the file. Alright. Where must lab 1102 INI reside in order for the malware to install properly? Well, we'll get to that. How is this malware installed for persistence? 4. It's the app init DLLs. Okay, so I'm going to hold there and get into the IDA Pro. Let me restart from snapshot. Close that out. Devo. IDA Pro. Okay. We gotta find out some about lab-o2.ini. And there's a procedure in here at the beginning of this program. Because we see it right here. This call right here gets the system directory and it concatenates it with the file name. And then there's an attempt to open that file with this create file, which is synonymous with create or open. And if it fails, it exits the program, so it's got to be in the system directory. I missed it. I didn't know there's a concatenate going on here. Or I guess I might have seen this, but I didn't put two and two together. However, I put lab-o2.ini in the system32 directory as well as the Windows directory. And root. Just in case. This looked like root to me at first. Alright, so it reads the file and then the whole thing about it is what's in that file. Excuse me. think what I want to do is, since it's already installed, we want to run DLL main and see what's going on in there. Yeah, so we're in DLL main right now, and this is showing DLL main trying to read the file. Let me go back here. Trying to see if there's something in here that we can find out what's in that file, because it does an attempted decryption. Read file. This sub right here. See the read, if the read fails it exits. If it succeeds it calls this subroutine. Which I had no idea this is what it's doing, but apparently it is. And then we can see, like, right here, we put a breakpoint on 1010 FD, because this is after the decryption is over. This time it made it. So we can find out what's been decrypted. Looking at it, I think EAX. Following nope. Not EAX. There it shows Billy at malwareanalysis.com, and you can save all of them. It's right there. You can save. Show task asking. That's HTML. Command. So obviously, it's hard to understand from the beginning what's going on without the answer, but still, following through, we can learn a lot, and the more programs we see, the better we're going to get at this, where eventually we'll know what's going on in a lot more cases. Okay, so that's a good network-based indicator. So there's something mentioned here. What user space rootkit technique does this malware employ? Well, I didn't know it was user space rootkit, but now I do. But apparently, since I read the entire answer, it's inline hooking. So it goes into the program during DLL main, and it looks further to see if it's one of three programs. One of those three that we saw in strings. The BAT, Outlook, or MSIMN. If the current program, which is this DLL is running in, is not one So apparently, look in IDA Pro, see, there's a lot going on, and I'm not going to get into the details because it's just too much. Let me hit back because we're in the decryption routine. It does something after decryption. This call. This is where it checks to see if it's one of these files, and if it's not, it exits. But then this is where it gets heavy. It gets the current process ID, and then it calls this routine, which see if there are any calls in here. Again, I'm not going to get too detailed into this. In the DLL, and it jumps to code which will insert an extra recipient on emails sent by those email programs. Okay, so back to the questions. What user space rootkit technique does this malware employ? Inline hooking, because it edits the procedure. It edits the import instead of changing the import address table address of the import to go to the malware version of the import. What is the significance of the INI file? It's the email, the extra recipient. How can you dynamically capture this malware's activity in Wireshark? Well, I attempted it. I spent a good long while trying to get email set up in Outlook, and it was only letting me set up encrypted email. So as far as like using POP3 instead of SMTP for the outgoing email, and that just did me in. I tried all kinds of different things, and then that's it. That's all I can do for this one. It's Lab 11-3. Analyze malware found in 11.3.exe and 11.3.dll. What interesting analysis leads can you discover using basic static analysis? To see the strings, I'm going to open IDA Pro. I've been getting used to that. It goes pretty good. So, excuse me. Looks like there might be well, this is an existing service, I do believe. So, it may impact that existing service. This file, it does not exist on the system, so it may copy the DLL to this file name. This looks like exactly the same. Now, if I look at imports, everything's from kernel 32. Get command line. May execute a command. Doesn't tell us a whole lot, but let's see what else. Loads the library. Write file. Create file mapping. That's a big one. May update a file or something. Map view of file, that usually means the file's updated in memory. Let me open the some error messages, mods. It's got a mutex, possibly. This is a file name that could be used as a host-based indicator. Imports, kernel 32, user 32. So here's the mutex again. Writes file. Now, I don't know what else to go through for basic static analysis, but we have some file names. What happens when you run this malware? There's 11.3.exe. Should be. There it is. The indexing service has started. You just stop procmod. Red shot, second shot. Compare. Looks like it did something with CISVC. Let me look up CISVC. So it's part of Microsoft Windows. Okay, let's see what else we have. I don't know what to make of any of the other stuff in the registry. But to see what's going on, we do filter. Process name. Lab 11-03.exe. Oh, that didn't come up with anything. It's mighty strict. Oh, I said relative time. I made a mistake there. No, this also means open file too, so. And this, I wonder if that file exists out there. Oh, there's a file. Since 23:59 p.m. That's recent. size, probably the same file. Okay, so looks like I put the DLL in system 32. That's about all I can figure out at this point. Basic dynamic analysis. Which Windows system file does the malware infect? Maybe this kernel 64x.dll. Makes me wonder if I can look at that file. Binary file. It's not a DLL. Let me open it in TextPad. Sharing violation. Uh-oh. Copy it. Copy. Paste. TextPad. This is weird, I just want to see all the text that's going in there. Instead of TextPad, I'm going to open with Notepad. Like it's hard to say what's going on with that. But this time keeps going up. We open that again. It looks like the commands I executed just now. Confirm file replace. Open kernel 32 Notepad. So it's recording commands. That's a log of the commands. Alright. And okay, so looks like we probably have all the answers even without looking in IDA Pro. But the fact is, I already looked in IDA Pro, and that's what led me towards that kernel 32 or whatever. Well, I read the answer to I read the question, where does the malware store the data it collects, and then I realized that kernel 32, well, that DLL that it was referring to could be the log, because there is no other file. So it is the log. But if we go into lab11.3.dll, I think in here somewhere it shows down there. I can say Control X. So it opens the file and calls the so it's using asynchronous key logging. There's a specific type of key logging as stated in Lab 11, or Chapter 11. Where's that? It's in here. I'm gonna find it. Here we go. Keystroke logging. User space keyloggers on page 239. Get async key state. That's what we see right there. Okay, hooking uses Windows API to notify the malware each time a key is pressed with set Windows hook. Now, that's a quote from the book. Now, this program does not use set Windows hook. It uses polling. Polling, this is a quote from the book, polling uses the Windows API to constantly poll the state of the keys, typically using the get async key state and get foreground window functions. Okay, that's all I need to know.